Hey, everybody. Today is day 9 from this chapter. We're going to be continuing with trigonometric identities. But just a quick check in, let you know where we are in the chapter. We're going to finish up trig identities today. That brings us to next week, where we are going to review on Monday and Tuesday for the unit circle test that will be on Thursday. That test will cover basically everything in the chapter. So all that unit circle trigonometry, we will have a review assignment for you to work on Monday and Tuesday, and I suppose Wednesday. I will be able to answer lots of questions on Tuesday. If you have other questions, you'll be able to ask them on Wednesday as well. If there's enough interest, if we want to schedule a Zoom meeting or something like that, we can certainly do that. But that is where we are headed next week. For today, I am going to remind you of the most important identity, the Pythagorean identity that was mentioned in the video on Tuesday. Thursday? I don't remember. Whatever the last video was. I suppose if you're watching this on Friday, that would have been put up for you guys on Thursday. But sine squared plus cosine squared equals 1. That's a big one. And we can take that equation and rearrange it. We can subtract cosine from both sides. We can subtract sine from both sides. So even though I've got 3 equations on my screen right now, really there are only one equation from this one. Sine squared plus cosine squared equals 1. And then these other 2 equations are just rearrangements of that equation. The rest of what I want to show you today as far as instruction goes, and I only have one key thing to show you, is that there are other identities that can be derived from this one. And the first one I'm going to get by taking this Pythagorean identity, sine squared plus cosine squared equals 1, and I'm going to divide the entire equation by sine squared, just like you've been doing in algebra for years. You can always subtract something from both sides of the equation. You can always divide both sides by 2. Well, for reasons that you'll see in just a moment, I'm going to divide everything in this equation by sine squared. And so what we end up getting when we do this is sine squared divided by sine squared. Of course, that's just 1. Cosine squared divided by sine squared. Well, sine divided by cosine is tangent, so cosine divided by sine is cotangent, and cosine squared divided by sine squared is cotangent squared. And then finally on the right side, 1 divided by sine squared is cosecant squared, the reciprocal of sine squared. And so this is another Pythagorean identity that's going to come in handy for us. If I see a 1 plus cotangent squared, I can replace that with cosecant squared. And I can rearrange this equation similar to how I did the previous equation. If I subtract cotangent from both sides of the equation, I get something that looks like this. And if I, let's see, subtract cosecant from both sides. No, I take it back. If I subtract 1 from both sides of the equation, I go from the top one down to this one. Basically, when you see a cotangent and a cosecant together, there's probably some manipulation that you can do. I can replace this with this. I can replace cosecant squared minus cotangent squared with 1, just like sine squared plus cosine squared equals 1. Cosecant squared minus cotangent squared is equal to 1. Now, I will say, in all honesty, this is not one that I recognize. When I see sine squared plus cosine squared, 1. I know that that's 1. That's one that I have got in my memory. This isn't one that I have in my memory. But if I was taking a test or a quiz that was covering this stuff, as you guys will on Thursday, at the top of my page, I would write down sine squared plus cosine squared equals 1. And maybe you're thinking, why would you write that down if you know that one? The reason I would write it down is so that I can go through this in my head and think, well, if I divide both sides of this equation by sine squared, I would probably write this one down coming from the one that I know. Sine squared divided by sine squared, cosine squared divided by sine squared, and 1 over sine squared. I would write 1 plus cotangent squared equals cosecant squared. I probably wouldn't write down the rest of these. Go ahead and put them all in your notes in the same place. You can refer to those as you're taking the test on Thursday. But these are also Pythagorean identities. And then finally, a similar manipulation. If I take this equation, my starting point, sine squared plus cosine squared equals 1. And if I divide both sides by cosine squared, something very similar is going to happen. Sine squared divided by cosine squared, of course, is tangent squared. Cosine squared divided by cosine squared is 1. Oops, I gave it away there. And then 1 divided by cosine squared is secant squared. And so this is the third equation that I would have written down. Sine squared plus cosine squared equals 1. 1 plus cotangent squared equals cosecant squared, and tangent squared plus 1 equals secant squared. So that if I see a tangent squared plus 1, if I see a secant squared, I can make this substitution. And if you want to spend a lot of time writing things down, write all three of these down. But these two bottom ones are just rearrangements of the top one, subtracting 1 from both sides, or subtracting tangent squared from both sides. So there we go. Those are all the identities. All I have left to do with you guys today is to go through a couple example problems, a few example problems. Maybe you'd say a plethora of example problems, starting with this one. Tangent squared minus sine squared times tangent squared. I'm actually going to do this one in two different ways, just to show you that there's more than one way to get from the beginning of these problems to the end of these problems. The first way I'm going to do this is by recognizing that this term and this term both have a tangent squared. So I can factor a tangent squared out of both of these. That gives me this, tangent squared times 1 minus sine squared. And then I notice, hey, 1 minus sine squared, that's one of my identities. 1 minus sine squared is cosine squared. So I make that replacement. And then tangent squared times cosine squared. I'm not sure if that's going to simplify any further, but I know I can write tangent squared as sine squared over cosine squared. And then I see that, yes, it will simplify farther because cosine squared divided by cosine squared cancels out, and this whole thing reduces to sine squared. Another way of approaching this exact same problem is to do what I know a lot of people do. When in doubt, switch everything over into sines and cosines. Replace those tangents with sines and cosines. So tangent squared is sine squared over cosine squared. And if I do that, I end up looking at these two fractions, sine squared over cosine squared and sine squared times sine squared over cosine squared. They've got the same denominator. And that's another thing to watch for. This fraction minus that fraction, I can combine those two together. Sine squared minus, well, sine squared times sine squared is sine to the fourth, all as one big fraction. And I feel like I'm making progress when I do that. Both of these terms on the top have sine squared, so I can factor out that sine squared. I'm left with 1 minus sine squared after I factor out that sine squared. And there it is again. Look at that. 1 minus sine squared is cosine squared. So I replace 1 minus sine squared with cosine squared. The cosine squareds cancel out. And I'm left with the same sine squared that I got doing it the other way, which is good. We should get the same thing even if you do it two different ways. So if you do it one way and then you check my answer key and I've done it differently, that doesn't mean you're wrong. That just means we did it in two different ways. And maybe you look at yours and maybe yours is easier than mine. Maybe mine's easier than yours. The next example I'd like to look at is actually one that we did yesterday. I suppose if you're doing this on Friday, this is one that you did yesterday on Thursday. If you're doing this on Saturday, then, well, who knows when you did the other one. But this is from the other video that I did. In the other video, I did lots of manipulation with this fraction. I wrote secant squared in the denominator as a cosine squared in the numerator, and then I combined these two ratios. What I'm going to do today is recognize, hey, cosecant squared minus cotangent squared. You just saw this like 5 minutes ago, so I don't expect you to have it memorized. I don't have it memorized, but I'm going to go back and look for this. Cosecant and cotangent. Which of these identities have cosecants and cotangents? There's one. Cosecant squared and cotangent squared. If I subtract cotangent squared from both sides of this equation, there's my cosecant squared minus cotangent squared. Hey, and that's equal to 1. That's good news. That means I can replace this whole thing, cosecant squared minus cotangent squared, with 1. And so we end up with 1 over secant squared plus sine squared. Well, 1 over secant squared, the reciprocal of secant is cosine. And so it's just cosine squared plus sine squared. And that's the one that everyone needs to have memorized. That is just simply 1, which is what we found yesterday. Actually, I think I should have that included in these notes. I believe it was the last one we did yesterday. Yep, there we go. So there's the manipulation that I did yesterday, combining fractions, doing a whole bunch of work, but we ended up with the same one that we got today. All right, moving right along. Let's see, the next one that I want to take a look at looks like this. 2 plus 2 tangent squared divided by secant squared. Again, simplify this expression. Got tangents on the top and secants on the bottom. I don't see any obvious replacement, so I'm going to see what happens if I factor out. I've got 2 in this term, I've got 2 in that term, so I'll factor a 2 out of both sides of this equation. And then there we go, 1 plus tangent squared. I check my identities to see, is this an identity? Is 1 plus tangent squared equal to something? And sure enough, it is. It's equal to secant squared. All right, this one's going to clean up nicely. Secant squared divided by secant. One of the secants on the top cancels out with the secant that's on the bottom, and I'm left with about as simple as I can get. I suppose if you want to, if you don't like reciprocal identities, whoops, we could say that this is the same as 2 divided by cosine. Generally speaking, if it says simplify in terms of a single ratio, I would probably write it as 2 times secant, but I don't think that's a big deal either way. Either one of these I would say is pretty simplified. And then my last example to look at today looks like this one. And the reason I wanted to take a look at this one is because it doesn't just say simplify, but it says solve. I want to find the value of theta that makes this true. We haven't seen a whole lot of equal signs in the examples that I've been doing today, except to say that this is equal to this, which is equal to that, which is equal to that as we simplify. But now I want to solve for what values is this true? This is not an identity. 1 plus cotangent squared is not equal to cosecant squared all the time, but it will be for some values. So if I want to solve this, I'm going to think about my identities. 1 plus cotangent squared, that is one of the identities that we found earlier. I'm going to scroll back and find where that is. 1 plus cotangent squared. Hey, sure enough, there it is. 1 plus cotangent squared is cosecant squared. And so I can make that replacement. This is cosecant squared. On the right side, I've got cosecant. Now, it's tempting at this point to look at this equation and divide by cosecant. You've got a cosecant on this side, you've got a cosecant on that side. I caution you against doing this because when you do that, you may lose solutions to this equation. Sometimes you can get away with it, sometimes you don't. I guess if you do it for this, I could divide both sides by cosecant, but then I need to make a mental note that cosecant could be equal to 0. And then I could go ahead and use algebra, but I would have to make that note if I was going to do it that way. I'm not going to do it that way. I'm going to do it this way instead. I'm going to bring everything over to the left side of the equation, which, by the way, I didn't do back here because I had 2 different ratios. And trying to solve with 2 different ratios was going to be a lot messier. Now I just have cosecant. And so I subtract cosecant over to the left side. Both of my terms have cosecant, so I can factor that out. And now this starts to look familiar. This times this is equal to 0, which means either this is equal to 0 or that's equal to 0. Cosecant is equal to 0. I was thinking about that before. Here I officially see it. Cosecant is equal to 0, which would mean sine is the reciprocal, 1 divided by 0, but that does not exist. So this equation does not give us a solution. Let's take a look at the other one. If cosecant of theta minus 1 is equal to 0, that means cosecant is 1. If cosecant is 1, that means sine is 1. And finally, we're back to the unit circle. For what value of theta is sine equal to 1? Maybe you're imagining the little unit circle in your head. But if I have a sine value that's 1, I must be up at the top of the unit circle. If I want an angle between 0 degrees and 360 degrees, my only answer is 90. If I want all real answers, then it would be 90 plus 360n, where n is an integer. I didn't specify on this one, and I think on your test it's not going to be a big deal. But I suppose all real solutions, I would have to say, I'm going to write this one out with text, I think. My answer would be 90 degrees plus 360n degrees, where n is an integer. So I could add 360 once, twice, 3 times, 10 times, or I could subtract 360 as many times as I want to, and that takes care of all of my possible answers. There we go. That is the end of the videos for this week. On Monday, we'll be reviewing for a test that will be on Thursday. As always, if you have questions, get in touch with me. Google Hangouts, email, If we want to coordinate a Zoom meeting, we can certainly do that, but I haven't heard anything from you guys about that. So I will assume that everybody is doing okay on that front. So have a great weekend, and I will see you next week. Bye bye.